So, good morning. Today we are going to present the PPT for uh, on the topic challenges with big data and navigating complexities in 2025. So, as we know, data has become a part of our lives. Data is driving everything from AI to basic logic on basic programming softwares as well. Okay, so as enterprises continue to generate a large amount of information, uh, this year presents five critical big data challenges demanding precise and actionable solutions. Exponential data volume and velocity. So, till the recent years, global data creation exceeded 120 zettabytes, which is a 23% increase from 2022, which was fueled by IoT, streaming, and a lot of other factors. For example, Netflix alone processes petabytes of real-time user interaction data daily via technologies like Kafka and Cassandra to refine its recommendation, uh, which directly impacts subscriber retention by up to 10% for them. Now the data variety and veracity complexities. A 2023 IBM study highlighted that poor data quality cost the US economy near to $3.1 trillion annually. Healthcare providers, for instance, struggle a lot to integrate unstructured physician notes from EHRS with structured patient billing data as well. Another topic is disparate data integration. Mergers and acquisitions exacerbate integration challenges. When Salesforce acquired Slack for close to $30 billion in 2020, unifying customer data was paramount. They utilized MuleSoft Anypoint platform to create APIs connecting CRM data with communication logs and reducing data silo issues by an estimated 40% within the first year. Heightened data security and governance. The average cost of a data breach reached close to $450,000 in 2023, uh, 15% rise in 3 years. Persistent data skill gap. 2020 McKinsey report projects a global shortage of 2.5 lakh data scientists by 2025. Financial institutions like JP Morgan Chase, despite investing billions of dollars in technology, face 6 to 9 month project delays in hiring AI/ML engineers proficient in Python and platforms like Databricks, essential for advanced fraud detection and market trend analysis. The big data bulge, unprecedented scale and critical stakes. The global big data and analytics market is experiencing a verifiable explosion projected to soar from an estimated $300 billion in 2023 to a strategically close to $700 billion by 2023, demonstrating a compound annual growth rate of 15% and more. This unprecedented data influx originates from diverse, rapidly expanding sources. Each minute, platforms like YouTube see over 500 hours of video uploaded, while Facebook users generate approximately 4 petabytes of data daily. The pro-filtration of IoT device is a major contributor, with predictions indicating over 25 billion active IoT connections by 2023 alone. Managing such immense scale renders traditional relational databases and on-premise storage solution obsolete. So the three V's that define big data challenges: volume, velocity, and variety. From volume, we can state that every minute approximately 500 hours of videos are uploaded, 3.5 lakh transactions, tweets are posted, and 1.4 million transactions are processed by Visa. This global data search contributes to the estimated 2.5 quintillion bytes data generated daily. Traditional relational databases and single server architectures like Oracle or SQL are overwhelmed. To handle this scale, companies like Meta and Amazon leverage distributed file systems such as HDFS and cloud object storage solutions like Amazon S3 to store hexabyte of data, processing it with frameworks like Apache Spark or Hadoop MapReduce. Velocity, the speed of which data streams in demand instant capture, processing and analysis. High frequency trading firms, for example, must analyze market data in microseconds to execute profitable trades, relying on technologies like Apache Kafka for real time data ingestion. Variety, a big data originates from a multitude of sources, presenting diverse formats, example, structured SQL databases, unstructured emails, and semi-structured JSON or XML files as well. Why 85% of big data projects fail? A deep dive into real-world challenges. The major issues driving the data quality issues, acute skill shortages, the human capital gap, absence of a holistic data strategy, navigating without a compass. These are some of the major issues which arises when a big data project fails. Despite significant investment and anticipation, a staggering 85% of big data projects either encounter substantial hurdles or outright fail to deliver on their promised value, a figure consistently reported by Gartner and reinforced by studies from New Vantage Partners. This high failure rate is not just a technology oversight but a symptom of fundamental operational and strategic deficiencies that undermine success across industries. Cybersecurity and privacy, the double-edged sword in big data. The aggregation of vast datasets while unlocking unparalleled insights also create lucrative and vulnerable targets for sophisticated cyber threats. Recent history is rife with example. In 2017, Equifax breach exposed the personal data of 147 million people, costing the company over close to $2 billion in settlements and compliances. Similarly, the 2021 Colonial Pipeline ransomware attack halted fuel distribution across the US East Coast, leading to a $4.4 million ransom payment and widespread disruption. Beyond direct financial losses from breaches, organizations face severe penalties under stringent privacy regulations. The General Data Protection Regulation in Europe has levied massive fines, such as the $746 million penalty against Amazon in 2021 for data processing violations. In the United States, the California Consumer Privacy Act imposes fine of up to $7,500 per violation. Real-time processing, the new frontier and its hurdles. Real-time processing, the imperative for instantaneous insights has propelled real-time data processing to the forefront of enterprise big data strategies. Leading companies like Netflix utilize Apache Kafka to stream user interaction data, enabling real-time personalized recommendations that drive engagement. Simultaneously, Uber also leverages Apache Spark for rapid in-memory analytics to power dynamic search pricing and optimize ride matching, demonstrating how these tools are indispensable for competitive advantage and operational efficiency. Complex architectures, the deployment maze. Implementing a high performance real time solution demands sophisticated, often distributed architectures. For instance, deploying a real time analytic pipeline using Kafka Flink on Kubernetes involves intricate configuration, managing stateful applications, and ensuring fault tolerance across potentially thousands of containers. Speed versus accuracy, the data integrity challenge. Balancing the need for millisecond latency processed with data accuracy is paramount. In financial trading, a real time system might process millions of transactions a second. However, a minor error due to a race condition or incomplete data can lead to a losses exceeding $1 million in minutes. Edge computing, securing a distributed frontier. Edge computing is implemented by companies like John Deere for autonomous farming equipment or major retail chains for in-store analytics. Data silos, the multi-million dollar barrier to unified insights and innovation. The factors affecting these are unified insights block, inconsistent standards, and emerging solutions. Skills and cultural gap, the hidden challenges in big data adoption. McKinsey's research consistently highlights that an estimated 70% of digital transformation projects fail, primarily due to cultural and change management issues, not technological shortcomings. Turning challenges into opportunities, the path forward. AI and ML driven data optimization, strategic cloud data platform migration, and embracing composable data architecture. Driving billions in value, the definitive big data advantage. Organizations that implement robust data governance, advanced analytics, and machine learning platforms are achieving tangible results. For example, JP Morgan Chase reduced fraud detection time by 70% using AI driven anomaly detection, preventing an estimated of $2 billion in potential losses annually. The future belongs to enterprises that embed a data first culture, invest in cutting edge technologies like ML ops, tools like Kubeflow and cloud native solution, etc. Okay, so thank you so much for